All right, guys, today we're going to take a look at quadratic equations when they're in vertex form specifically. Vertex form, I've got it up here in red in the upper right corner. It focuses on identifying the vertex simply by looking at the equation itself. There's lots of different forms we look at with quadratics. You deal with standard form and you deal with factored form and vertex form and some other things. And I'll be posting other videos on how you convert from one of those forms to the other. This video specifically just focuses on identifying key information from an equation in vertex form and then using that to graph the equation. Okay, so the first thing I'm going to point out on vertex form, and I'll kind of talk through this as we go. You can see my example I'm going to be referencing here in blue. The example says y equals x plus 2 squared minus 4. Now, there are different parts in the normal form of vertex form that you need to understand what they mean because you can see there's a lot of variables at work here. And so I'm going to start and kind of go from left to right. First off, y and x, hopefully you would understand that that's just the x and y values at any given point on the graph. Also, a key kind of background knowledge, any quadratic equation is going to graph like a parabola, which is that U-shaped or hill-shaped graph that we'll see shortly. A, when you look at the variable A is going to be a number, some value. Sometimes it's that understood 1, sometimes it's a different value. And there's a couple of different things you can tell from A. First off, A tells you whether the graph is going to open upward like this or downward like this. And the idea is this. If A is a positive number, the graph's going to open up. If A is a negative number, the graph's going to open down. And so because of that, you can simply look at whatever that value happens to be, and then you can say, okay, well, based on that, I know what the graph's going to do. The other thing A tells you is the width of the parabola itself. If A is 1, that's kind of that standard parabola that we're used to seeing. If A is greater than 1, then that's going to widen your parabola and it's going to look more like this. If A is less than 1, it's going to make your parabola very skinny and you're going to look like this. And so A kind of gives you just an idea. It tells you a lot of things about the shape of the graph itself. Okay, so looking at the example I have, notice there's not a number there in front of the parentheses. This is that understood 1, which means A is positive, which means it's going to open upward. Okay, the next thing you would want to identify is the vertex of the parabola, and that comes from HK. Now, this is probably the part that more students struggle with identifying correctly than just about anything else on vertex form, not because the numbers are difficult to see, but because of the signs. We can look at the example. It's very clear the numeric value of H is going to be 2, and the numeric value of K is going to be 4. But what we have to look at are the signs. Notice in the normal form of vertex form up here that the H is being subtracted. I teach my students, when you see this, think the opposite of H. So when I look at the actual example, it's plus 2. What's the opposite of plus 2? That would be minus 2. And that is the H value, the true H value. Now, K reacts just completely differently. I teach my students, when you look at K, it's plus K, so think the same. So whatever my sign is in my example, in this case negative, it is going to be negative. So the vertex of this parabola that opens up is going to be located at -2 and -4. Now, the next two pieces of information that are really important that you can find are the x and the y intercepts. And just like with any linear equation or any other type of equation, the way to do that, if you want to find the x intercepts, which is where that crosses the x-axis, right? I'm going to substitute substitute 0 in the place of y. So 0 equals x plus 2 squared minus 4. And when I go to solve this, it's going to tell me my x-intercepts. So the first thing I would do to solve would be to add 4 to both sides. That leaves me with 4 equals x plus 2 squared. Then I would take the square root of both sides, remembering that 4 has 2 square roots. It's either going to be positive or negative 2, and that equals x plus 2. And then my final step would be to subtract 2 on both sides. I end up with negative 2 plus or minus 2 equals x. So when I look at what that comes out to, negative 2 plus 2, that's going to be 0. Negative 2 minus 2 is going to be negative 4. And so those are going to be the 2 places on the x-axis that it crosses, 0 and negative 4. The y-intercept works almost the exact same way, except you're going to plug in 0 in the place of x. So starting with my original equation, I have y equals, I have y equals 0 plus 2 squared minus 4. Oh, 0 plus 2 is 2, and 2 squared is 4. 4 minus 4 equals 0. So the parabola is going to cross the y-axis at 0. So this gives me a lot of points to work with. I can begin the process of graphing now, and I'm always going to start with that vertex. I know because my A is positive that I should have a parabola that opens up. And so here we go. Negative 2, negative 4, well, that's going to graph right here. And that's going to be my vertex. Negative 2, negative 4. Specifically, this is a minimum because it shows the lowest point on this parabola. If the parabola happened to open down, the vertex would be a maximum. The next 2 points I'm going to graph are going to be my x-intercepts. It says that it crosses the x-axis at 0, which is right here, and it crosses it at negative 4, which is right here. And so I'm going to go ahead and label those points. The x-coordinate is negative 4, the y-coordinate is 0. In this case, the x and y-coordinate happens to be 0. And then notice my y-intercept here is 0, which actually makes sense. My point going through the origin is not only crossing the x-axis, but it's crossing the y. And so I can connect my parabola and have a fairly accurate picture of what that should look like. Now, bear in mind, this is hand sketched. This is not done with a precision piece of technology by any stretch of the imagination. But this is how you would get this important information from vertex form. One last thing I'm going to leave you with is an idea about parabolas in general. Parabolas are, by definition, symmetrical. Based on that, that means there's a line that would divide a parabola and make it 2 perfectly equal halves. That line is called the axis of symmetry, and it goes through the minimum or maximum. In this case, the axis of symmetry is located at x equals negative 2. That line is your axis of symmetry. And so, as I said, this is just a brief introduction to the idea of vertex form, and hopefully it answers some questions and kind of gets you into the idea of what this looks like. Later on, I'll look at converting equations from standard form to factored form to vertex form and vice versa.